The power of plasma can clean your world.
Labs like this invest hundreds of thousands of dollars in laboratory automation each year, and yet struggle with the most basic of lab tasks, ensuring that carryover is minimized and that automated assays run efficiently. Long and complicated tip washing methods don't eliminate the risk of contamination at the sample or consumable levels, and the cost to buy and handle disposable tips is enormous. Either way, automated environments are subject to unpredictability and high cost. How can screening departments run more efficiently and gain maximum benefit from their investment in automation? By adding a tip charger cleaning station onto your automated liquid handler, you can clean, sterilize, and reuse your pipette tips in just seconds. When dirty tips enter the tip charger cleaning station, an optical sensor is switched on. Without any special gases or temperature controls, regular room air is ionized by high voltage to form plasma. It's this plasma that ionizes and removes contaminants on the exterior surfaces of tips. And by building a series of aspirate and dispense steps into the liquid handling protocol, plasma is pulled deep inside the tip. The induction of atmospheric plasma begins with the capturing of free electrons between dielectric plates to form an electromagnetic field. Through changes in polarity, these electrons are forced to mobilize between a set of plates, a virtual electron avalanche. By drawing air in between these plates and through the electron field, the components of air are bombarded with electrons, room air fractures, and a cold plasma field is formed. In addition, metastable atomic species are generated, and these highly reactive electrons combine with the oxidizing free radicals. This unique combination promotes the removal of contaminants from pipetting surfaces. So unlike traditional solvent-based tip washing methods, plasma cleaning doesn't simply dilute contaminants, but removes them at a molecular level. Tips are clean and sterile and ready for another pipetting step. Look at the differences between sterilizing with plasma and diluting with solvents or bleaches. Traditionally, after a reagent is transferred, tips are rinsed in a solvent. Tips move to the next station without any guarantee that chemicals or biologicals have been sufficiently diluted. In many cases, wash buffers themselves become a source of contamination, affecting downstream results. On the other hand, a minimal plasma exposure produces a truly clean and sterile tip you can reuse at least hundreds of times with no detectable adverse effects on either pipetting precision or accuracy. Many labs seek to avoid contamination risks by using disposable tips one time only, but with screens requiring 10, 20, or even 100 tip boxes per day, tip box storage takes over valuable lab space. And although it becomes routine, the logistics of loading, delivering, and unloading new tip boxes cause scientists and lab managers countless hours of frustration and time lost to more important tasks. Imagine having the ability to use fixed washable tips, or just one tip box per assay or screen with tip charger. And instead of rinsing metal cannulae and pin tools in bleach or alcohol, tip charger delivers equivalent or better results while reducing a 3 to 5 minute wash protocol down to less than 20 seconds for genomic, biological, biochemical, and immunoassay screens. By eliminating bleach from the wash protocol, you also eliminate the costs, environmental impact, and risks of managing hazardous waste. Tip charger cleaning stations are available in 8, 96, and 384 SBS standard footprints. Using tip charger translates to faster and more efficient assay runs, higher quality results without contamination, and a more productive laboratory.
The power of plasma can clean your world.